very much for the kind introduction. So today I want to talk about how we as DataCamp learn from our learners. And to be more specific, I want to zoom in on how we use data to inform us what to teach. And then second of all, how to teach it. And thirdly, how we use data internally to improve our own product, DataCamp. So I saw some of you are already familiar with what we do, but there are quite a few people who also have not logged into DataCamp yet. So I want to take some time to talk about what DataCamp is. Our mission is to help both individuals as well as companies at every step of their journey to become data fluent, data literate, by building the smartest education platform out there. And we take that very seriously, and we've grown quite a bit in the last few years. We now have over 2.3 million learners, and that number is still growing at over 120 to 150,000 users every month. So it's a really exciting place to be, the data science education market right now. And if you think about who comes to DataCamp, who are these people learning data science, there's really three different groups. On the one hand, there's existing data scientists who want to advance their existing skill sets. On the other hand, there's aspiring data scientists, people who want to pursue a career in data science in the future. And then finally, there's also a large group that doesn't even self-identify as a data analyst or a data scientist. They're just people working with data on a regular basis. Could be weekly, could be monthly, and they realize that there are better ways to handle data than for example, Microsoft Excel or Tableau. They want to get ahead in their career, and they want to take a step further. So they might be working in financial services, in healthcare, in consulting, in marketing, in a multitude of roles, and they want to learn Python or R or SQL to get better at getting insights out of their data. We also help over 600 businesses retrain their workforce. That ranges from small teams from 10 to 20 people to really large corporations where we train over hundreds of people or sometimes thousands of people. And then on the flip side, what we offer is a course curriculum. And we now have over 110 courses. Some of these courses cover Python. Some of them are SQL, Git, Shell, and so on. And the courses are built by external instructors. We have people from both academia as well as industry who are experts in certain domains who create all these courses. And there are some really good instructors from Anaconda who've taught multiple courses on DataCamp. So I definitely would advise you to check those out. Now, before diving into how we at DataCamp use data to improve our product and improve our course curriculum, I want to quickly introduce how we think about our product. And essentially, our product is a combination of technology as well as didactical content. And if you think about our learning philosophy, really, we expect learners to go through a three-step iterative process of learning, practicing, and building. And that is based on both research on how people learn, as well as on our own data, and our goal to create a really fun and engaging learning experience. Because the dirty secret of online education is that a lot of people start courses, but very few of them finish courses. So really the key thing to look at is how can we make it really engaging and really fun to learn on DataCamp so people actually finish courses and actually learn. The first step in this process is learning. So going from zero to actually understanding a topic, and we have multiple interactive learning interfaces where students get to experience the real thing. This is one of our interfaces where students have to solve a Python challenge. On the top left side, you see the assignment, giving some context to the students. On the bottom left side, you see the instructions. Instructions tell students what to do. And then there's an editor where students can fill in some code, they can run the code, which get executed on the platform, or they can submit the answer and then they'll get feedback whether they that tells them whether they get it right or wrong. Now, students go through these challenges and they gradually learn about a certain topic. But even after they've done that, that doesn't necessarily mean they are fluent in a certain topic. So the second part of our learning experience is focused on building data fluency. And we have small, bite-sized challenges that people go through for 5 to 10 minutes, and that help them to gain fluency. Because it's a well-known fact that spaced repetition really helps to retain knowledge. That's also why we've started switching a lot of these practice problems to our mobile app. So people can on a daily basis, can just pull up their phone and practice the syntax of R, Python, SQL, and so on. Now, the final step when you're learning, so once you've learned the topic and you've gained some fluency, at the end of the day, what you really want is you want to be able to apply that to real-world data science problems. And that's where our projects interface comes in. So using a Jupyter Notebook-style interface, students get to complete real data science projects on real data. And we give them some guidance, but they're more free than in our previous learning interfaces. And that helps them really on the way to the real world. Now, obviously, all these types of content have to be created. So we also have a teaching platform as a core part of our product. If you're curious about that, you can go to datacamp.com/teach. Anyone can create courses, practice problems, or projects on DataCamp. It's mostly used by our external instructors in our content team, but we also have enterprise clients who've used our teaching platform to build in-house content. So that's really exciting. And that brings me to the final part of our product, which is DataCamp for Business. DataCamp for Business really makes it easy for small and large groups of people to learn data science online. And we recently launched a new interface that makes it easy to give assignments to both individuals as well as to subgroups of people, and to monitor how they're learning. This is not just used by enterprises, by the way. This is also used by over 1,000 professors who use DataCamp for Business in the classroom. And if you have any questions on this, we have a booth outside, and there are a few people who would be happy to answer any questions on DataCamp for Business. Okay, that's the end of the sales part of the presentation. Now I want to zoom in on how we at DataCamp learn from our learners. And there's really 3 things I want to touch upon. How do we determine what to teach? How do we improve our curriculum? And how do we improve our product? Let's start with the first one. How do we determine what to teach? And obviously, we have an internal content team that has an expert opinion on this. But in addition to that, we look at data from the market as well as data from our students to determine what to teach. Let's start with the first one. Let's look at some data from the market. So we're looking here at data from Stack Overflow. Our chief data scientist, Dave Robinson, used to work there, and he did some really interesting work on the popularity of software languages and platforms. And what he used as a proxy for popularity is really the number of visits to Stack Overflow questions with certain tags. So a tag could be Python or R or Scala or so on. And then on the vertical axis here, you see the year-over-year growth in views to those questions. So that's a proxy for the year-over-year growth of the popularity of that software language. And then on the horizontal axis, you see the relative, say, market share of these different languages. And this really proves that data science education is an amazing place to be right now, because if you look at the 2 really fast-growing languages, close to 30% year-over-year growth, you see R and Python up there. And what's even more striking is that Python is doing so from while being a really large software language compared to the other ones. Because if you look at the horizontal axis, you'll note that this is a log scale. Let's look at that over time. So on the horizontal axis now, you have time. On the vertical axis, you have number of views for a certain software language. And what you see here in red is the growth, the incredible growth of Python over time, which is even accelerating in recent times. So it went from being roughly the 6th popular software language to being the number 1 language here. So you could ask yourself, what is driving that growth? Because Python is a general purpose programming language. It's not only used for data science, it's used for a multitude of things. So what is driving that growth, and how can we figure out the answer to that question? So one approach would be to look at the popularity of different Python packages over time. Django, as some of you may know, is a web development framework written in Python. Pandas is a really popular package for data manipulation. NumPy, Matplotlib, also used for data analysis and data science. And as you can see from the graph, while Django is roughly flat, so there's not really a lot of growth there, the growth is really driven by the software packages that are used for data analysis and data science, and especially the growth of pandas is just off the charts. And this was for DataCamp a strong indicator that we wanted to build multiple pandas courses, and we did so in collaboration with Anaconda. So we're really excited about that. Now I want to zoom in a little bit deeper on Python's growth and the Python ecosystem by looking at the correlations between different tags. So what we're looking at here is what are the tags on Stack Overflow that Python visitors are also visiting. And you see a couple of interesting patterns emerge here. So on the left-hand side, you see that there's a group of Python users that is visiting tags like Ubuntu, SSH, Shell. Those are your system administrators. And then on the bottom of the slide, you see people in web development, AngularJS, and so on. But then the center of the graph contains packages that are very heavily used in data science. And the color of the nodes here indicates the growth of these tags. So as you can see, the dark orange/red, there is Keras and TensorFlow. So one of the fastest growing areas within data science is obviously machine learning, and this is something we can clearly see from that data. So that was an input to the fact that we as DataCamp really wanted to invest in more machine learning courses. And this is totally in line with the data we see from our own students, by the way. So we constantly survey our users on what they want to learn next. This is based on over 22,000 survey responses. As you can see here, the number one thing our students request is machine learning. Don't get confused by the colors. So red here indicates Python users, and green is R users. So what you observe as well is not only is machine learning the most requested topic, but also it confirms something that you might have known anecdotally. Python users are, relatively speaking, more interested in machine learning than R users. On the flip side, R users are, relatively speaking, more interested in things like bioinformatics and statistics. So it's really fascinating that some of these things that you might know to be true, we can actually observe that in our data. And then finally, and this is more of a fun fact, this doesn't necessarily have a lot of business value, but we have both learning paths for R and Python. Overall, students are roughly 50-50 between the two, even though we see much more growth on the Python side. So Python will overtake in terms of like the popularity on DataCamp as well. But what's fascinating is that different countries have different appetite for different software languages. So some countries like France and Singapore and India, relatively speaking, there's more Python users than R users. And then in some countries, it's the reverse. We haven't really done more research to figure out exactly why that's the case. But if anyone has any ideas on that, definitely an interesting topic to debate. Now, the next question I want to focus on is how do we improve our curriculum? And before we dive into that, I just want to help you understand how much data we currently have to do that. There's over 100 million completed exercises on DataCamp right now. So we have enormous amounts of data on how people learn Python. And I want to quickly give you a few examples of how we use that data to improve our existing curriculum. So this graph shows the completions of our most popular Python course, Introduction to Python. So it's the absolute beginners. And on the vertical axis, you have the number of people that complete a certain exercise. And on the horizontal axis, you have all the different exercises in that course. This course covers Python basics, lists in Python, functions and packages, and eventually a basic introduction to NumPy. What you can see from the graph is what you would expect. There's a small group of people that just wants to have a peek at the course and then drops off. And then there's a slowly decaying function of completion of the course. Now, if you zoom in one level deeper, then we can look at, for these different exercises, how many people actually need the solution to complete the exercise. So if you're stuck as a student on DataCamp, you can request a solution, which is basically telling us, like, okay, I give up. I need a solution. And we closely monitor how many people do that for every exercise, because we need a balance there. If nobody requests a solution, that means it's way too easy. People will get bored and drop off. If typically more than 10% needs the solution on an exercise, it's probably too difficult. And we should try to understand why people have trouble with that specific exercise. So one bar plot here indicates the percentage of students that need the solution for this specific exercise. So just to give you an example, there's one exercise where very few people request a solution. That's a very simple one where I can't really see it, but they're asked to get the type and the length of a variable, so that's a really easy one. But then later in the course, it gets really hard. At least for absolute beginners, they're learning NumPy, and they're looking at to-do arrays, and there's more than 10% of the people that actually needs the solution to finish this. Now, where it gets really interesting is if you go one level deeper and try to understand why students are struggling with specific exercise. What are the specific mistakes a lot of students are making on this exercise? Because we have data on that as well. And I just wanted to give you a couple of examples of that. So in the second chapter, the second exercise of the Intro to Python course, students are asked to create a list. And a very common mistake with beginners is, even though these are variables, they use quotes around the variables. In another exercise in the third chapter, people forget the parentheses. And so there's two ways we can use that data. We can try to make the instructions or the assignments clearer. But also, we have an automated grader that gives feedback to the students. So we can use the typical mistakes students make to give them better feedback and to help them find the solution and help them understand the didactical mistake they're making better. Now, that's during a course. As I said, the second part in our learning process is practice sessions. It's where students build fluency. And that really allows us to understand, after students have taken a course, what are the common misconceptions at that point in time. And I quickly wanted to share two interesting examples here. The first one is list concatenation. And only 56% of students remember that number 3 is the right answer here. A lot of people choose number 4 on that first challenge. And one hypothesis we have is this is actually people assume this is vectorized, which is the case in R, but it's not in Python. And so this is definitely an interesting insight. that can inform us to improve our Introduction to Python course. And then the second example is on importing a specific function from a package. And there you just see that a lot of people just don't remember the syntax initially. And this points to the importance of really practicing and spaced repetition to retain the knowledge better. So those are just two small examples. Okay, then finally, I want to talk about how we use data internally to improve our own products. And this is really no different from any data science project. Like, you start by collecting the data, you analyze the data, but then it changes. You decide on the actions. You can test IDs in the product, and then we eventually integrate those changes into the product. And then finally, we monitor metrics. So I quickly wanted to show you our basic learning interface again. So on the top left side, you have the assignment. Bottom left, the instructions. Then there's the code editor where students go in and they try to come up with the solution. And so really every student goes through a learning flow. They read the assignment, read the instructions, they try to come up with the answer, they write the code, they run the code, see what it gives them, and then they submit the answer. If it's not correct, they can get they get feedback, they can go back, edit the code. If it's still not correct, they can ask a hint. If it's still not correct, they can ask for the solution. And they can go through this as many times as they want. As a company, really what we're optimizing for is we don't want people to get into the red box. If they're too frustrated, if they really don't get it, they'll abandon the exercise. So one of the things we really look for is how can we make sure the completion of each exercise is as high as possible. And our head of product research has done some interesting analysis on that they'll talk about now. So obviously one hypothesis is the longer courses are, the lower the completion rate of the course on aggregate is going to be. So surprise, surprise, that actually seems to be the case. Now, there's much more nuanced things you can look at. So you can wonder, like, what about the length of the instructions? What about the length of the assignment? What about prerequisites? Does it matter whether a student actually has taken the prerequisites we think they should take? What about the total number of exercises in a course? To what extent is there fatigue if a course is too long? And the key conclusions of this research are that it matters a lot whether or not a student takes the prerequisite courses. That is one of the key things that makes students drop out of a course. The second thing that was really obvious from the data is it matters a lot how long the instructions are. If the instructions are too long, and this is a well-known fact in research on learning, then there's cognitive overload, and then students just don't get it and eventually get demotivated and they abandon the exercise. So to put that into perspective, first column is the instruction length in terms of number of characters. So it's from 0 to 100 characters, 100 to 200, and so on. And then let's zoom in on the last column here, the completion rate of that exercise. So first of all these numbers seem really, really high. So it's like 99.71 completion rate of people that start the exercise that actually completed. But I just want to point out this compounds over 40 to 50 exercises. So if all of the exercises would be in the first category, the course completion rate will be roughly 88 point something. If all of the exercises would be in the lowest category, you end up with a course completion rate of, I think, 58% or something. So this really matters, like losing people, only a small fraction of people on every exercise compounds to completion rates that are substantially lower. Okay, so based on all of that research and all of the analysis we did on what drives students to complete exercises on DataCamp, we came up with a couple of actions. One of them is we created content guidelines for our instructors. basically giving people advice on how long should instructions be, how long should assignments be, and so on. So here's a long list of some of the guidelines we came up with based on that research. The second thing we realized is maybe there's a way we can change the product to reduce the cognitive overload. And we came up with a new exercise type called the bullet exercise, where you complete the instructions in different steps. And this really reduces the cognitive overload and really increases the completion rate of students of these exercises. All right, so this is the last, this is the final part. And our head of content, Nick, is gonna talk about a new approach to data science skill assessment and certification. And this is a really excited new product we've been working on for a while with our partner Anaconda, but I don't want to steal Nick's thunder. So Nick, come up the stage and you can take it from here.
Okay, I was really enjoying life on that side of the podium, but here we are. My name is Nick. I lead the content team at DataCamp. Next 15 minutes, I would like to give you a sneak peek of one of our newest offerings at DataCamp, which we see as a fundamentally different approach to data science skill assessment and certification. And that is the Anaconda Data Science Certification. So this is something that I'm personally very excited about. Our team at DataCamp, along with a group of experts at Anaconda, have been working pretty hard on this over the past year. And as you may have heard from Anaconda's CEO, Scott Collison, yesterday, this is very recently now live on DataCamp and available to everybody. The basic premise of this certification, the reason we created it, is that we heard a common refrain from a lot of our customers, and these are folks ranging from like Fortune 500 companies to like individual aspiring data scientists, as Jonathan mentioned, is people wanted something that went beyond just simple completion certificates. People wanted skill validation. They wanted a standard for data science knowledge. And that's what we really set out to accomplish with this. So just a few high-level points, and then I want to dive into some of the specifics of how the certification works. So at a high level, we really wanted to create something that was trustworthy and credible. So in the certification world, if people don't trust the certification, then it will have no value. So we wanted to make sure that we made it hard for people to cheat. We wanted to make sure that the content was created by actual experts. That's why we wanted to partner with a group like Anaconda on this versus creating all of the content ourselves. We also wanted to make sure that the material was not just a bunch of multiple choice questions strung together. It was really important to us and to Anaconda that we were checking for real data science skills, for the ability to apply data science understanding. And so this goes beyond just checking conceptual understanding. This means actually asking people to apply knowledge in a real-world context, similar to some of the things that Jonathan showed earlier, and I'll show how we're using some of those same tools in a certification context in a minute here. Okay, this is also 2018, so we wanted to make sure that what we did was very convenient, very affordable. So we wanted to make sure people could get set up really quickly, that they could do it from home on their own laptop. We wanted to make setup quick and easy, so we need to have certain security checks in place, but you can get through that initial process in just a few minutes. We wanted to make sure people got results quickly after they took the exam. And we also wanted to keep the cost relatively low. So I'll explain sort of the setup of the certification, but you've got a series of like individual skill-based modules, and then once an exam taker completes those individual modules, they unlock a more comprehensive exam that covers the gamut of topics. So looking at total cost for the entire certification is about $2,800, which relative to, obviously, formal degree programs is significantly less expensive. And we also tried to come in on the low end compared to other professional certifications that exist in other disciplines in the market. All right, so this is a very, very high-level breakdown of the different topics that we cover. So as I said, you've got the 7 skill-based modules listed here, along with a comprehensive project at the end. Now, each of these individual modules, or I should say each of the 7 skill-based modules actually has 2 components. There's an hour-long assessment, which is a collection of small, bite-sized challenges that might be multiple choice, but also include writing code, filling in the blanks, drag and drop exercises, that sort of thing. And then the second part of each module is an hour-long, more open-ended data science project. The comprehensive is a 2-hour-long open-ended project. All right, so a quick glimpse at what the experience actually looks and feels like. So I'm just going to kind of walk you through one of the modules, which is data visualization. So this is the landing page for the module. One of the first things you see is a few DataCamp courses that you could consider to be suggested prerequisites, things that will arm you with some of the knowledge that you need to complete the exam successfully. We opt into the exam, and now we're in it. So first thing we do is we're going to set up the environment and do a few security checks. So we want to make sure people are not wearing headphones. This was me at the airport very early yesterday morning, looking pretty rough. But we asked the person to record themselves saying 1, 2, 3, and then play that back and confirm that they can see and hear themselves properly. Basically, that their camera and microphone are working on their computer because they will be recorded while they're taking the exam. Then we ask them to pay us. So they can do credit card, or there's the option to apply a coupon, which might be provided by your employer if they purchased in bulk. Then we photograph both sides of an ID. This could be a driver's license, government-issued ID, passport, etc. Take some personal information, and then a few words of wisdom before they get started. So the first thing here is important. As soon as they start the exam, we force them into a full screen mode. So this is for security purposes. So we don't want them poking around on other websites, looking up the answers as they're going through the exam. We're just making it clear you can't get any outside help. Nobody can be in the room with you. Turn off notifications so that you don't accidentally exit the exam partway through by checking Facebook. And then setup is done, you're good to go. So that's a few minutes of work. And then you're in the exam. So the full exam, as I mentioned, takes 2 hours to complete. In most cases, actually a couple of the modules, we gave an extra 30 minutes for the project because they're a bit more substantial. But part 1 is the assessment. So this is a series of 30 challenges. You have up to an hour to complete those. And I'm going to give you like half of a preview of one challenge because I don't want to give away the answers. But in this particular case, you see some context at the top. You're asked a question. You have to interpret this plot, and then you're given a series of answers that you can select from below. Another question asking what plot type gives a clear indication of the median of a distribution, and you have some options to select from there. And then I failed to include examples of this, but as Jonathan mentioned earlier, some of these challenges actually do require you to enter code either manually by typing it in or dragging and dropping different options to complete the code. Okay, done with part 1, now entering part 2, the project. So again, you've got 60 minutes to complete the project. It's a little bit more open-ended. We use our interface that we've built around the Jupyter Notebook that Jonathan showed you earlier. On the right-hand side, again, just to reiterate, you have a Jupyter Notebook that is pre-filled with what you might consider to be like the skeleton of a data analysis. There's like a narrative in place here, but it's your job, the exam taker, to complete the narrative. On the left-hand side, you have a series of tasks to complete, which map to different portions of the notebook, and you have to fill in the code cells. You can obviously run the code. You can check whether certain tests are passing, and ultimately you submit your final response, and then you're done there. Okay, so once you've completed the exam, then we upload the video recording. So this is a recording of the exam taker's screen the entire time that they're in the exam, as well as a recording of them individually. So their webcam is on the entire time. And this video gets uploaded, and on the other end we have actual like real-life human reviewers, people who watch these videos and ensure that no cheating took place. And there's also some automated flags as people are going through the exam that get set off if certain actions are taken that are likely to be indicative of cheating. Okay, so then at this point, the exam taker waits for their results. Initially, this waiting period is going to be a few weeks. Because this is brand new, we want to take our time and make sure that we get it right. Eventually, we're going to compress that down to hopefully less than 72 hours turnaround time from the time the exam is done to when somebody gets their final results. And then if the exam taker is successful, they will see something like this, where they have the option to print their certificate for the module or share it on various social media. Okay, so I want to talk very quickly about the curriculum, exactly what is the content that is being evaluated in the certification. Now, I want to state a disclaimer up front. DataCamp primarily was responsible for building the platform to host the certification. The true content experts are the folks at Anaconda. So if you have very, very specific questions about the actual content in the certification, feel free to go talk to the people at the Anaconda booth. I know Albert DeFusco was over there earlier, and David Mertz as well. They're both experts in this area, and they can certainly answer any questions that I don't. All right, so I'm going to walk you through just a very, very high level what each of the modules are, and then I'm also going to, on each of these slides, you're going to see like just a list of DataCamp courses. If you're thinking about doing this, they might be helpful to you in preparing you for that particular module. So in this case, the first module, data import and export, it's exactly as it sounds, how to get data into and out of Python for data analysis. So this means managing data both on a local and a remote machine. And we've got a few importing databases courses that would prepare you for this, as well as an introduction to databases in Python. The next one is data manipulation and analysis. So we've got a series of Panda courses that we created in collaboration with the folks at Anaconda. And here it's heavy focus on pandas, cleaning, transforming, summarizing, filtering data, etc. Then we've got DataViz, which you got a quick preview of already. So this is covering both static and interactive data visualizations, understanding when it's appropriate to use various plot types with different types of data, how to build a reusable DataViz pipeline, and many of these topics are covered in the courses I list here. Stats, so statistical analysis and inference gets into how do you take a business problem and formulate that in statistical terms. So you get some stuff in here about A/B testing, construction of hypotheses, identifying different sources of error in the data. So we've got some stats courses on DataCamp that can help prepare you there. On the machine learning side, the machine learning module covers both supervised and unsupervised learning. Gets into pre-processing data, tuning hyperparameters, assessing model performance, and so on. So again, some suggested DataCamp courses here that go along with that module. And again, I just want to reiterate, these courses are not required to complete the certification. They're simply suggested if you want to brush up on some of the material that will be tested. Data science at scale covers working with large data sets, working with data out of core, streaming data, distributed and parallel computing. Dask is heavily featured in this module, and we've also recently developed a course, again, in partnership with Anaconda around parallel computing with Dask. And then finally, on the skill-based modules, we've got an Anaconda Foundations module, which is coming soon. So we're still working on this. It should be rolled out very shortly, but this gets into working with Conda environments, Anaconda projects, building Conda packages, and so on. And there will be a couple of courses also built by Anaconda that help you prepare for the material in this module. Okay, so once you've completed all 7 of the skill-based modules, then you've got the comprehensive project. And again, the purpose here is to bring everything together into a single coherent data analysis to test your abilities as a data scientist. And that is it for me. We'll now take questions.